Hello students, welcome to EPG Pathshala. I am Dr. Sumandua from Department of Anthropology, University of Delhi. Today we are going to discuss about the module Energy Value of Foods under paper Human Growth, Development and Nutrition. So students, let us see what we are going to learn in this module. To understand about food energy and its values, we will also know about the requirements of energy for various purposes by human beings. To know the amount of food energy and the analytical methods used for the same. What is meant by energy expenditure and the methods to study the same. As you know, green leaves make food using sunlight during photosynthesis. The energy stored in the food is known as the chemical energy. The energy stored gets converted into muscular energy when we eat it. This is by the process of respiration. The human body requires energy for maintaining body temperature, metabolic activities, physical work, and growth. Dietary energy intake from the food must satisfy these requirements for the proper functioning of the body, which is very much essential for optimal health. The energy or the caloric value of the foods depend upon the energy yielding factors in them. Classically, we measure this by bomb calorimeter. Human body utilizes potential energy in foods for maintaining life processes and for doing work. The energy yielding food factors are carbohydrates, proteins, and fats. In cells, enzymes degrade carbohydrates, proteins, and fats by oxidation, thereby producing energy. Carbohydrates and fats give carbon dioxide, water, and heat, while proteins also give urea along with these. The energy or calorific value of food depends on the amount of energy yielding factors in them. This can be determined by oxidation in a bomb calorimeter. Units of energy include calorie. 1 calorie is the quantity of heat needed to raise the temperature of 1 kilogram of water to 1 degree Celsius. Kilogram calorie or kilocalorie more accurately defines calorie. The joule or kilojoules is the standard international SI unit for expressing food energy. To convert kilocalories to kilojoules, multiply the kilocalorie value by 4.184. The slide shows you the following conversions which can take place. The slide gives you an overview of food energy flow through the body for maintenance of energy balance. There are two types of food energy: metabolizable energy and net metabolizable energy. Metabolizable energy, it is the food energy available for heat production and body gains at nitrogen and energy balance. The net metabolizable energy is the food energy available for body functions which require ATP. That is, it is based on the ATP producing capacity of foods and on total heat producing capacity. A large number of analytical methods for food analysis have been developed since the late 19th century. So have a variety of different energy conversion factors for foods. The common ones are the Atwater system, extensive general factor system, and Atwater specific factor system. All of these are based on ME, that is the metabolizable energy. The energy values based on Atwater system are given for proteins, fats, carbohydrates, and alcohols. The extensive general factor system has been obtained by making refinements, additions, and modifications to the Atwater general factor system. For the division of total carbohydrate into available carbohydrate and fiber, more factors were needed. Moon's saccharin as an added factor for available carbohydrate was added by Southgate and Dernin. Different weights for carbohydrate were obtained by measuring directly or considering the difference between them. Fiber is assumed to 70% fermentable. The energy generated by fermentation is lost in the form of gas, while some of it is incorporated in colonic bacteria and goes into feces. General factors are also used for alcohols, organic acids. The next is the Atwater specific factor system. Merrill and Watt made a refinement of the Atwater system. According to this, there are ranges in heats of combustion and in the coefficients of digestibility of different proteins, fat, and total carbohydrate. Proteins different in amino acid composition, heats of combustion, etc. Heat of combustion of protein in rice is more as compared to potatoes. Different energy factors should be used for them. Even the milling process affects the digestibility of different flours also. This system is definitely superior to original Atwater system. The next system, that is the net metabolizable energy system, are based on metabolizable energy. However, values can be modified to account for energy that is lost in heat from different substrates and will not be available for production of ATP. This results in NME factors. The differences between the metabolizable energy and net metabolizable energy factors are found in estimating the energy content of proteins, carbohydrates, and alcohol. The next system is the hybrid system. Different countries use different systems based on countries' food composition, databases, and regulations of food liabilities. There is considerable confusion due to array of conversion factors as well as analytical methods. The discrepancies arise for carbohydrates, fibers, etc. The participants at fibers, etc. The participants at FAO Technical Workshop 2004 reached on consensus that continued use of the ME rather than the NME factors is recommended. Determination of energy value of foods is done by bomb calorimeter. It measures the total or gross energy value of various food macronutrients. Bomb calorimeters operate on the principle of direct calorimetry, measuring the heat liberated as the food burns completely. Heat of combustion refers to the heat liberated by oxidizing a specific food. It represents the food's total energy value. Humans need food energy to cover basal metabolic rate, the metabolic response to food, the energy cost of physical activities, and accretion of new tissue during growth and pregnancy, as well as the production of milk during lactation. Energy balance is achieved when input or dietary energy intake is equal to output or energy expenditure plus the energy cost of growth in childhood and pregnancy or the energy cost to produce milk during lactation. This has been given by the Food and Agricultural Organization of United Nations 2004. When we see the food energy flow through the body for maintenance of energy balance, then the ingested energy is equal to the digestible energy, the metabolizable energy, the net metabolizable energy, and the energy which is used in the other processes. Bomb calorimeter, which is used to burn foods, is used to determine the enthalpy of combustion for hydrocarbons. Other calorimeters are also used for the same. They are the Benedict's oxycalorimeter, measures the volume of oxygen required to burn a known weight of food. Direct calorimeter is used to see the relation between energy output and oxygen consumed has been determined using the human respiration calorimeter. For example, adult weighing 65 kilograms, the amount of heat output in 24 hours would be 2400 kilocalories, whereas the amount of oxygen consumed in 24 hours would be 500 liters, whereas the heat output per liter of oxygen consumed would be 4.8 kilocalories. So, the physiological energy value of foods vary from that seen in the bomb calorimeter. A bomb calorimeter, carbohydrates and fats are completely oxidized to carbon dioxide and water and protein with nitrogen. But in human beings body, this may not be affected. The vegetable fibers are burnt in calorimeter, but the body doesn't actually utilize them for energy. Also, in utilization and digestion, certain percentage of each is lost and the nitrogen is mainly excreted as urea. Loss in digestion, for example, in Western countries, is about 2% for carbohydrates, 5% for fats, and 8% for proteins. The loss of energy in metabolism due to incomplete oxygen is no loss occurs as far as the carbohydrates are concerned and also the fats are concerned. But for proteins, a part of the energy is lost as urea due to incomplete oxidation and is estimated to be about 1.2 calories per gram of protein oxidized. Thus, the Atwater-Bryant factors show the physiological energy value of foods. So, the physiological energy values of food vary from that's in the bomb calorimeter. In bomb calorimeter, carbohydrates and fats are completely oxidized to carbon dioxide and water and protein with nitrogen. But in human body, this may not be affected. The vegetable fibers are burnt in calorimeter while human body does not actually utilize them for energy. Also, in utilization and digestion, certain percentage of each is lost and nitrogen is mainly excreted as urea. Loss in digestion, for example, in Western countries, there is 2% for carbohydrates, 5% for fats, and 8% for proteins. Loss of energy is not there for carbohydrates and fats during metabolism due to incomplete oxidation. But for proteins, a part of energy is lost as urea due to incomplete oxidation and is estimated as 1.2 calories per gram of protein oxidized. Thus, the Atwater-Bryant factors show the physiological energy values of foods. Knowledge of nutritional value of foods is important. Many governments have made it a rule to include nutritional labels in food packets. Respiratory quotient is very important to be known when we talk about energy value of foods. Respiratory quotient is the ratio of volume of carbon dioxide given out and the volume of oxygen consumed by human subjects. When only carbohydrate is oxidized, the respiratory quotient is 1. For fats, the respiratory quotient is 0.7. For proteins, the respiratory quotient is 0.82. In the post-absorptive stage of an average meal with 10% protein, 20% fat, and 70% carbohydrates, respiratory quotient is about 0.82. Respiratory quotient is measured using Ganong's respirometer. One of the important terms is basal metabolism. It is the energy metabolism of a subject at complete physical and mental rest and having normal body temperature and 12 hours have passed after the intake of last meal. Basal metabolism can be measured using a Benedict Roth apparatus. Basal metabolic rate is the minimum amount of energy our body requires to complete its normal functions such as breathing, breaking down food, and for heart and brain functions. Resting metabolic rate is the calories burned by the subject at rest. It is synonymous with resting energy expenditure or REE. BMR varies from person to person and increases with your amount of muscle tissue. BMR increases due to exercise and it can remain high after 30 minutes of moderate physical activity. Individual variations are there. The average is about 70 calories per hour. BMR is measured when a person is awake but at complete rest under very restrictive circumstances, and for accurate BMR measurement, the person's sympathetic nervous system should not be stimulated. RMR is measured under less strict conditions. About 70% of a human's total energy expenditure is due to the basal life processes within the organs of the body. 20% of one's energy expenditure comes from physical activity and another 10% from thermogenesis or digestion of food. Measurements of basal metabolic rate or RMR are measured by gas analysis through either direct or indirect calorimetry, though a rough estimation can be acquired through an equation using age, sex, height, and weight. Also, there are several formulas to calculate the approximate BMR of an individual. Dubois and Dubois found a formula to calculate the body surface area of a human being A as shown, where h is the height in centimeters and W is the weight in kilograms. A standard table was plotted for BMR against age, sex, and surface area in square meters. Basal metabolic rate formula takes several variables like height, weight, age, and gender to calculate your calorie needs as if you did not do any exercise. The metric BMR formula is calculated for women as BMR is equal to 655 plus 9.6 into weight in kilos plus 1.8 into height in centimeters minus 4.7 into age. For men, it is equal to 66 plus 13.7 into weight in kilos plus 5 into height in centimeters minus 6.8 into age. The calorie calculation has been given in the table. If you are sedentary, then it is BMR into 1.2. If you are lightly active, it is BMR into 1.375. If you are moderately active, it is BMR into 1.55. If you are very active, it is BMR into 1.725, and if you are extremely active, it is BMR into 1.9. The BMR formula uses the variables of height, weight, age, and gender to calculate the basal metabolic rate. This is more accurate than calculating calorie needs based on body weight alone. The only factor it omits is lean body mass, and thus the ratio of muscle to fat a body has. Leaner bodies need more calories than less leaner ones. Therefore, this equation will be very accurate in all, but the very muscular will underestimate calorie needs and the very fat will overestimate calorie needs. Factors affecting basal metabolic rate. Men have greater muscle mass and a lower body fat percentage. Men therefore have a higher basal metabolic rate. Genes. Some individuals are born with fast metabolism, others with a slower metabolism. Age. BMR reduces as one gets older. After 20 years, it drops by 2% per decade. Exercise helps raise your BMR by building extra lean tissue. Lean tissue is more metabolically demanding than fat tissue. Weight. The heavier you are, the higher your BMR. Body surface area. A tall, thin person will have a higher BMR than a shorter, fatter person. BMR also increases in pregnant women. Body fat percentage. The more lean tissue on the body, the higher the BMR. The more fatty body tissue, the lower the BMR. Men generally have a 10 to 15% faster BMR than women. Diet. Starvation or serious abrupt calorie reduction can dramatically reduce BMR by up to 30%. Restrictive low calorie weight loss diets can cause your BMR to drop as much as 20%, which is also known as the postprandial thermogenesis. BMR and RMR are measured by gas analysis through either direct or indirect calorimetry, though a rough estimation can be acquired through an equation using age, sex, height, and weight. Also, there are several formulas to calculate the approximate BMR of an individual. Dubois and Dubois found a formula to calculate the body surface area of a human being A as W raised to the power 0.425 multiplied by H raised to the power 0.725 multiplied by 71.84, where H stands for height in centimeters and W stands for weight in kilograms. A standard table was plotted for BMR against age, sex, and surface area in square meters. Harris-Benedict formula takes the number produced by the BMR formula and multiplies it depending on your activity level. Basal metabolic rate BMR formula takes several variables like height, weight, age, and gender to calculate your calorie needs as if you did not do any exercise. Along with other factors, the type of food we eat can also have a significant effect on our basal metabolic rate. Protein-rich foods have the greatest effect, with carbohydrates and fats eliciting a smaller impact. High-fat foods and refined sugars, however, can reduce the BMR since they are lower in fiber and bulk. Proper amount of vitamins and minerals can help regulate BMR to keep that process efficient. Other factors also include hormones. In terms of BMR, the most influential hormone is thyroxine, which is produced by the thyroid gland. One function of thyroxine is to regulate BMR. Higher levels of thyroxine lead to a greater BMR. Thyroxine release can be affected negatively through extreme dieting. Testosterone, which is a sex hormone, promotes BMR. Estrogens also increases BMR, but less in comparison to testosterone because of less metabolic activity in females. Cortisol is the only hormone showing both the catabolic activity as in fever. It increases BMR as temperature increases, and anabolic activity as in sleep. It decreases BMR up to 10 to 15%. Growth hormone also increases the BMR. The more muscle fiber, the higher your BMR, as muscle, even at rest, burns significantly more calories and the fat than the other tissues. This is the reason that strength training is so important to a weight loss program. Aerobics and cardio exercises are good to a point, but if underdone or overdone, for example, if they are overdone, can actually break down muscle tissues for energy, which can be counterproductive to weight loss. An efficient exercise program, therefore, will include both cardio and strength training. Then there are other factors like hereditary factors can influence the basal metabolism. People who seem to eat voraciously sometimes never seem to gain weight. You know why? Because while others who normally don't have very good diets get weight easily, the child with no obese parents has only 10% risk of becoming obese, whereas a child with one obese parent has a 40% risk, and a one which have two obese parents has a 80% of becoming obese. Now the temporary factors which we see can affect BMR, they include fever, because BMR increases during fever. And another temporary factor is stress. If you have stress, then the hormones also raise your basal metabolic rate. Stress causes the release of hormones adrenaline and non-adrenaline, which increases the cellular metabolism. Then there are factors such as temperature also. Temperature may increase BMR due to heat and cold. As our body temperature increases, the rate with which our bodies use energy also increases. Indeed, 1% increase in body temperature can elicit an increase in BMR in the region of 10%. Sleep also, if you talk about, then during sleep, then BMR falls by 10% below the level when a person is awake. There are climatic conditions also which can cause a change in BMR. For example, BMR, people who live in cold climate conditions have a higher BMR as compared to people living in hot climates. Then things like caffeine and tobacco can also increase the metabolic activity. Certain medications such as antidepressants can modify BMR, leading to weight gain. Then after an injury, BMR can increase temporarily while the body uses EFAs and proteins to rebuild the damaged structures and create new tissues. Gives the energy stores in man carbohydrates, triglycerols, and protein. It also gives the energy as well as water, and the water is dry wet, and the total energy stored, that is 840 for carbohydrates, then 135,000 for triglycerols, and 24,000 for proteins. Energy requirement depends upon calorie burning, heavy and light individuals, type of work or exercise, age and other physiological characteristics, and basal metabolic rate, type of exercise and calories burned, energy requirements based on age, whether the subject belongs to infant age group, children, or adults, based on body weight and height, and based on conditions like pregnancy, lactation, etc. Recommended dietary allowance is different for different countries. Geographical divisions like tropical or equatorial or polar, and also different according to age and sex. The needs of calories in is taken complete diet, macro and micronutrients also affects the recommended dietary allowance. Among Indians, based on a reference, the standard values are tabulated, and for the Indian reference man, it is 2780 kilocalories per day, and Indian reference women is 2080 kilocalories per day. Obesity is a condition in which our energy intake exceeds our energy expenditure. So, in order to reduce weight, our energy expenditure must exceed our energy intake. This can be done by taking low calorie foods and negative calorie foods. Body mass index is defined as the individual's body weight, which is in kilograms, divided by the square of his or her height, which is in meters. Based on body mass index, the individuals can be categorized into normal weight, underweight, overweight, and obese. So students, let us summarize what we have learned in this module. What we have seen is that the recommended requirements of energy should be assessed in terms of energy expenditure rather than energy intake. The energy requirements can therefore, in terms of measures of energy expenditure, plus the energy needs for growth, pregnancy, and lactation. Body weight is an important indicator of the energy intake of our body in order to find out whether the intake is adequate or not. The energy balance can be achieved when the dietary energy intake is equal to the output, which should be there for a prolonged period. Thank you.